In a previous video we looked at LU factorization, so what we're going to be looking at now is something called Crouts method. Now Crouts method uses an LU factorization of a coefficient matrix to solve a linear system. So we want to solve a linear system of the form AX equals B. So this is a standard manner in which we represent a linear system. A is a coefficient matrix, X is our vector of unknowns, and B is our constant vector. Now since using LU factorization, A equals L times U, we can rewrite our linear systems LU X equals B. Okay, and if we let a new vector Y be equal to UX, okay, so what this means is we have Ly equals B. Now remember, L is lower triangular, so for example what we'll have is we'll have 1, we'll have L2 1, let's say L3 1, okay, 1 is L3 2. This is for a 3 by 3 system, for example. Okay, so what we'll have is something like this. Oh, that's not a vector. We'll have a lower triangular coefficient matrix multiplied by a vector of unknowns, which is Y, and that's equal to some constant vector B's. Okay, so this is our L, that's our Y, and that equals our constant vector B. Okay, now because this is a lower triangular in nature, what we can do is we can do forward substitution to calculate it. So for example, Y1 is easily calculated to be the same as B1. So once you've calculated Y1, you know that whatever L21 times Y1 plus 1 B2 minus that is going to be equal to Y2, and similar for Y3. So Y3 is going to be equal to B3 minus L31 times whatever Y1 is minus L32 times whatever Y2 is. Okay, so we can use forward substitution. So we can calculate what our vector Y is by using forward substitution on the system Ly equals B. Now since we let Y equals Ux, we can then calculate X by solving Ux equals Y. Okay, so we can just solve that. So if we look at what Ux equals Y would be for a 3 by 3, for example, just writing out a 3 by 3 U matrix. That's 3 3, isn't it? Okay, our unknowns are going to be our unknown values for X, and that's going to be equal to our Y values, so ones we calculated using the forward substitution earlier. So that's U, that's our vector X, and that's our vector Y. Okay, and we do this using back substitution. Okay, so Crouts method, when you're presented with an LU factorization of the coefficient matrix A, we use forward substitution to calculate our values for Y, and then you use the Y on the right hand side of the equation Ux equals Y and calculate X, which is our solution to the original system, using back substitution. Okay, so let's have a look at an example of that in action. Okay, so I'm going to follow example 6.3 in the notes, and the 6.3, so I'm just going to write out the linear system. Now this, if you just watched the previous video on LU factorization, this matrix will be familiar to you because we just calculated what the LU factorization was. And that's equal to a constant vector minus 7, 11 and 1. So that's your A, that's your X, and that's your B. Right, so in a previous video we calculated the LU factorization. If you're unsure about that, or you haven't watched that video yet, I suggest you stop this video now and go and watch the video on LU factorization. So we have L is a lower triangular matrix, U is our upper triangular matrix. Right, okay. So Crouts method, we're going to solve for Ly equals b. Okay, so to solve for Ly equals b, we have our L, our unknown values y1, y2 and y3, and our constant vector on the right hand side. So trivially, it's quite trivial for the first one, y1 is simply equal to -7. Okay, now y2 is going to be equal to 11 minus 2 lots of whatever y1 was. So that's 11 minus 2 times 7, so that's 25. Okay, and y3 is going to be equal to 1, which is our b3, plus, you're going to say plus because it's -3 here, so it's plus 3 lots of y1, and another plus because we've got a -1 here, 1 lots of y2. So it's 1 plus 3 times -7, so that's -21, so that's going to be -20, plus 25, so that's equal to 5. Okay, so we know that we have our y value now, so the second step, and let's change colour just because I can. It's nice to change colour every now and again. You'll get bored if I always use the same colour. Okay, so now we solve for ux equals y. Okay, so u was our upper triangular matrix, and 0, -1, 1. Okay, our unknowns are x, and our y values of what we just calculated. Ooh, I've got the equal sign. So we just calculated -7, 25, and 5. Okay, so so we did this, the y values using forward substitution. We're going to calculate the x values using back substitution. So x3, so 1x3 is equal to 5, so that's quite easy. Actually I should have said that's equal to y3, it's equal to 5. x2, okay, so the coefficient of x2 is -10, so we're going to have 1 over -10 to start with. Then we're going to have 25 minus -1 times x3, so that's going to be plus 5, so that's going to be -3. Okay, and x1 is going to be equal to the coefficient of x1 is 1, so technically speaking that's 1 over 1. We're going to have -7 minus 3 lots of x2, so that's going to be plus 3 times 3, plus 0 lots or 0 times x3, so that's going to close that there. So -7 plus 9 is 2. Okay, so our solution to this system of equations is x1 is 2, x2 is -3, and x3 is 5. Okay, so we've used LU factorization to calculate the solution of a linear system. Now you might think, well hang on, I can do that using a number of methods, for example Gaussian elimination. But what's good about LU factorization is, because we factorize the coefficient matrix A, it doesn't matter whether the B values change. So let's say we had a different set of B values, we'd still use the same LU factorization. So once you've calculated L and U, you can just use straightforward Crouts method with forward substitution and back substitution.